Okay, this is our second video from section 2.2 on rational numbers, operations with decimals, rational numbers in decimal form. Our first question here in our exemplar says negative 1.4 times negative 2.6, and it says to first estimate. So if I'm going to make this into an estimation, I'm going to make that negative 1 multiplied by negative 3. I'm going to round it to the greatest place values. And once I round it to the nearest place values, negative 1 times negative 3, my estimation for this question will be a positive 3. Okay, this is actually a lot easier than the adding and subtracting because it doesn't require any convoluted trains of thought for when you're looking for the addition of negatives and positives, actually the difference or the subtraction of them, which is kind of a complicated idea. But in this show, we're just multiplying, so we know that we have 1.4 and 2.6. We know our answer is going to be positive. So all we're going to do here is we're going to drop our negative signs, and in fact, we can drop our decimals too. We don't even need decimals here. I'm just going to put the two numbers like that next to each other with no decimals. And I'm going to multiply them using that algorithm of multiplication that you learned a long time ago. We're going to take our 6 and we're going to multiply it by our 4 to get 24. We're going to carry our 2, and then we're going to go 6 multiplied by 1, which is 6, plus 2, which is 8. Then we're going to go to our second number. We're going to put a 0 down, and we're going to start our second number, which is 2. 2 times 4, which is 8, and 2 times 1, which is 2. And then we're going to add those together to get 4, 16, 3. So I get 364, but that's not really our answer, 364. What I'm then going to do is I'm going to use that number, that 364, to then place my decimal according to my estimation. Since my estimation was 3, I'm going to put that right there, and my calculation will be positive 3.64. Now, of course, if you wanted to, your parents are going to tell you that there was an easier way to do it, and your parents will tell you they didn't drop the decimals. They just kept it 1.4 times 2.6. They did the same thing, but then what they did is they took their decimal places. They said there's one decimal place here, there's another one here, that's 2 decimal places. So in my answer, I'm going to put 2 decimal places, and my answer is 3.64. That's what your parents will tell you. But the new curriculum says to just use your estimation for decimal placement. But it's up to you. Any questions on that one? We're good? All right. The second one is the most difficult one that kids have, which is dividing. So bear with me here as we do this because it's not as complicated as you think. So with decimals, what I want you to think about first is money. I want you to always associate division of decimals with money, and it's going to make more sense. No pun intended. With my calculation, do I know before I do any work whether or not my answer is going to be positive or negative? Yes, I know for sure because I'm dividing a negative by a positive. I know for sure that both my estimation and my calculation are going to be negative, right? Because I know my sign rules. And here's what I want you to think. I want you to think about this number here, the first number in your division question, as how much money I have. How much money I have. And I want you to think of the second one is dividing it into piles this big, pile size. Okay, this is kind of complicated. This is my own one. I didn't get this from anywhere. I just kind of use it myself. And how much money I have is the first number, and the size of the pile you want to make with that money is the second number. So in this first question, this example here, I have $2.76, and I'm required to take that money and pile it up into piles of $4.60. Now, if you think about that, do you have enough money to make a pile of $4.60? No. Do you have enough money to make more than half a pile of $4.60? How much money would you need to make half a pile of 460? You need to have $2.30, right? But you have $2.76, which would mean you can make just a little bit more than half. So when I think about that, I have enough money to make just a little bit more than half. I'm going to say my estimation, I'm going to just make it like this. I'm just going to say something silly like 0.56. I don't know what it is, but I know it's a little bit more than half. So since half is 0.5, I'm going to make my estimation 0.56. Okay. Now, I'm going to show you the long division way, and then after that you can just say, you know what, I'm never using that again. So if I think about negative 2.76 divided by 4.6, and if I think of it as being a fraction, it would be negative 2.76 over 4.6. I want you to look at those two, and even though it's not a fraction, and even though you can write it like that, and it would still be the same thing. Agreed? So once we have it like that, if I didn't want to use decimals, and I wanted to just divide without decimals, I could multiply both the numerator and denominator of that particular question by 100. I didn't choose 10, I chose 100. Why did I choose 100 to multiply both top and bottom? Why not just 10? Why would I not just multiply by 10? Because if I did that, when you multiply by 10, you move the decimal one place. Multiplying it by 10 would only move my decimal place once in my equivalent fraction, which does not get rid of the decimal. But if I multiply it by 100, I'm going to get negative 276, because I'm going to move my decimal twice for 100. And I'm going to move the decimal twice here. It's going to be 460. All right? Let's go back in time. That was my original question. I thought of that question in fraction form, which has decimals. I considered, what do I have to multiply both numerator and denominator to create an equivalent fraction that doesn't have decimals? So the exact same question would be negative 276 divided into piles of 400. That's the same question in terms of quantity, right? It's just multiplied by a factor of 100. And that question's a lot easier because we don't have to worry about decimals. So I have 276 divided by 460. How many 460s are there in 276? There are 0. So I'm going to put a 0 up here. My decimal's there. My decimal's there. 0 here. Subtract 276. Now I got to bring down something. What can I bring down here? Well, 276 is 276.000. I can just bring down zeros. So now I bring down a 0. And my next question is, how many 460s are there in 2,760? Not an easy question. What's our gut say? Is there 5 of them? What's 5 400s? 2,000. What's 5 60s? 240. We have enough for 5 of them. Do we have enough for 6 of them? Pretty close. Do we have enough for 6? Let's check. I'm going to multiply this by 6. 0, 36. 36, sorry, 36 and 270. We have exactly 6 460s in 2,760, which means the 6 goes up here, and we're done. My estimation, my calculation, without using a calculator is 0.6. Okay. Now here's the good news. You want the good news now? Everything I just did here that I'm about to erase, you don't have to do. I'm not going to assess it. I'm not going to assess your ability to divide long division without a calculator. What I do want you to be able to do for assessment purposes is this here. Do this, and then you're going to just grab a calculator and do the actual calculation. If you can calculate using that money idea, I have $2.76 divided into piles of 460, and you could do that without a calculator, then Bob's your uncle. You're doing really good. Okay, let's try 2 more exemplars. Oh, not that one. So what I'd like you to do now is just take these 2 questions, give them a go, see if you can estimate both of them and calculate both of them. If you want to try the second question with calculating using long division, you can, but just do your estimation first using those piles of money, and then use your calculator to see what the actual calculation is. Press pause, press unpause when you're ready to see what the answer is. Okay, so now let's try and see how this works out. So the first thing to do is estimate, and when you estimate, you're going to make this negative 5, because when it's right in the middle, you're going to round up, multiplied by negative 3. So my estimation is going to be a positive 15. That's what I believe my answer to be. Now, if you go old school or new school, it's up to you. It doesn't matter. Either way is fine. I'm going to go 4.5. I'm going to go old school. Multiplied by 2.9 9 times 5 is 45, carry your 4. 9 times 4 is 36. 36 plus 4 is 40. Second number is 2, leave a space or a 0, doesn't matter. 2 times 5 is 10, I'm going to carry my 1. And 2 times 4 is 8, plus 1 is 9. Add them together, you get 5, 0, 13. One decimal place here, one decimal place there means 2 in total. My calculation will be a positive. I guess I can just bring this over. Oh no, I can't. Huh. Sorry, buddy. I got to erase you and put you over here. My calculation, a positive 13.05. My estimation was 15. In the second question, remember what we said before. This is how much money you have. I have $10.25 divided into piles of $4.20. Can I make one pile? Yes. Can I make two piles? Yes, because two piles would be $8.40. Can I make three piles? No, because that would be $12.60. But I can make, in my head, I'm thinking two, maybe 2.5 piles. Maybe. So my estimation is going to be a negative 2.5 because I'm dividing a negative by a positive using my sign rules. I know it's going to be negative. I then take my calculator and say, what is 10.25 divided by 4.2? And the answer is 2.4404761,907, which is approximately negative 2.44 is your rounded calculation. Your rounded calculation. Was my estimation close? Yeah. Was it exact? No, that's not what estimations do, but it does give you a ballpark idea for the quotient for a division problem.